All right, welcome back. We're on our third topic now. This is the second part to research design, where we're talking specifically about different types of data. So let's go ahead and pull up those slides. All right, so types of data. So remember that statistics are numbers used to describe data from a sample, right? But not all data is treated equally, right? We can't describe everything with numbers or with values. So we're going to start off on that very topic, that there are two major distinctions with data. We have quantitative data, which is information about quantities or information that can be measured or written down with numbers. And then we have qualitative data or information about qualities. Information that can't actually be measured. All right, so focus in on the kind of terms we use to describe this here. While qualitative data can't be measured, it can be, say, counted or totaled or summed. So we'll take a look at some examples of that here to come. And why are we concerned with this? We're concerned because the type of data we have, whether quantitative or qualitative, will determine what type of statistics we can run on the data. And when we start doing statistics or math in our next topic, we'll see an example of this. So let's take a look at the four major types of data that we'll be looking at here today. We have four major types of data: nominal, ordinal, interval, and ratio. All right, each of these are distinct in what they can tell us about any given information. So on the next slide here, I have a sort of a flow chart of these categories. So this is good for reference, kind of starting off here, but we are going to go into each of these separately. So we have quantitative data and qualitative data. All right, so we have information that can be measured with numbers and information that can't. And when we move from the most restrictive type of data up to the least restrictive type of data, so to speak. So we move from data that is categorical or in categories, then into data that has some type of order, ordinal data, and then interval data, which we'll expand on, and ratio data, which is more of our number line data, data that we can think of as a scale. So we're going to flesh all of these out individually, but something I do like to start with is this little comic here. About the difference between qualitative and quantitative data, right? You might think to yourself, well, numbers are stronger than words, right, when it comes to explaining something in science. But that's not entirely true. There are some variables, some things that we simply cannot measure using numbers. So I'll give you a minute to get a good laugh at this, right? I try, anyway, to give us the occasional laugh. Okay, but here we are. All right, different types of data. So let's start to think about how we can implement these types of data, or what these types of data can help us to describe, right? Because that's what we're trying to do with statistics. Let's start with nominal data, and let's get my head out of the way. All right, so with nominal data, we have qualitative or categorical variables. Okay, remember, variables are anything that can vary. So here on the right, we have a graph about chocolate preferences, right? An individual's preference for chocolate can vary, right? We have here a list of different types of chocolate. And what we can do is, while these categories are not numeric, right, we can't assign a number to, say, someone enjoying dark chocolate, but we can sum up, right, or get a frequency of the amount of people that prefer each of these categories. So we ultimately end up describing this data with numbers, but the data itself is non-numeric. So we can think of a couple other examples of this, things like gender, eye color, hair color, We have lots of different categories that we use for research, and there's no inherent order to them, right? So taking this, for example, we might have a personal way that we would rank these different chocolates from best to worst, but that's not going to apply to everybody, right? So there's no inherent order to the categories here in nominal data. We have a couple other terms we use to describe categorical data. There are binomial variables, which means that there are only two categories. That's one of our simplest types of variables. Again, variables are anything that can vary, anything that has multiple options. So a binomial variable could be something as simple as a yes or no question, right? Maybe, are you employed? Yes or no, right? Only two options. We have a few other words for this, okay? So we have binomial. This can also be called dichotomous or binary, just for some extra confusion, right? We have three terms for the same thing, but again, prefix bi meaning two, dichotomous also meaning two, and binary, kind of like our computer language, which will come into play later when we're starting to work with computer softwares to take a look at data. We use binary coding to help us out. And then sometimes we have numbers masquerading as categories, all right? This is why nominal data can be a little bit tricky. Take a postal code, for example. Here's one listed here. This is a number, right? This is a value. Maybe you live in a postal code that's higher than this one. But if the number of your postal code is higher than another, that doesn't mean anything numerically, right? They're simply numbers meant as labels for categories. So the key word here is really categories, all right? Nominal data is categorical data, or data that can fall into categories. One step up from this, we have what we call ordinal data. Ordinal is a bit like how it sounds in that there's an order to the data, right? There's no inherent order to nominal data, but there is an order to ordinal data. We put data into a rank order system here. So these are numeric variables in which the values are ranks or relative order on some characteristic. So a couple examples, your class standing, right? What place are you, so to speak? Place you finished in a race. And for the ladies out there, dress sizes, right? Dress sizes are kind of an enigma, right? All sorts of numbers we use to describe dress sizes, but if we take a conventional system, things like 0, 2, 4, 6, and 8, we know for sure that 8 is larger than 6, but something that we're going to point out with this type of data is there's not a guaranteed equal distance between each of the measures on these scales. For example, if 3 people finish a race, the distance between the first and second finisher might not be the same as the distance between the second and third finisher, right? So rank kind of eliminates some specific information, right? But sometimes it's the best we have. I have an example here about peppers, wanting to rate them from the most hot to the least hot, right? You could taste all of these peppers and put them in some type of ranked order from the spiciest to the least spicy. But we can brainstorm maybe some very hot peppers, right? We have the Carolina Reaper, we have ghost peppers, and we could probably think of some not very spicy peppers as well, things like bell peppers or jalapenos. So we can rank them, right? We could put them in a rank order, but it doesn't mean that the distance between the spiciness of each pepper is equal, but it does mean that we have an inherent order to the characteristics that are being measured. So when does this come into play? All right, what's the big deal with this? There are plenty of variables that we're interested in measuring that we can only really measure on a scale like this. Let's take a look at some of these here. We maybe recognize what these are. These are pain rating scales, maybe seen in hospitals or other medical care facilities. So if you go into a medical care facility and they ask you, rank your pain, right? What is your pain at? From 0 to 10, this is the most common anyway, when we see lots of different makeups of this very same scale, right? The top scale, we have a nonverbal scale, meaning there's no wording on the scale. And we have some color and images to help guide the intensity of the selections here. And then the second one is a more kind of cut and dry scale, right? With just text indicating from no pain to moderate pain to worst possible pain. So pain is a difficult variable in itself because everyone experiences pain differently, all right? We can't feel somebody else's pain unless we develop the technology as seen in Black Mirror. But we can't feel other people's pain, right? So we have to rely on what we call self-report. People have to self-report their pain, and we ask them to report it in this type of ranking system. The issue here, though, is these go in an order, right? If someone reports one day that they're at a 10 and then the next day they're at a 9, we can say, okay, their pain has reduced. But we can't necessarily say that the distance between a pain rating of 9 and 10 is the same as we would see on the other end of the scale between a 0 and a 1. So this is a big issue for psychologists. This is one of the issues I mentioned that are really relevant to this class. And why is this class specific to psychology? Because we have specific considerations when it comes to measuring variables we're interested in. There's a disorder called fibromyalgia, which is a nerve pain disorder. We'll do an example using some data from people who have fibromyalgia next topic. But we're interested in measuring pain. It's an informative variable, right? But we don't have an entirely reliable way of measuring it. So here's a couple more pain scales for fun, right? The one on top is a more personalized scale, perhaps, also 0 to 10, but we have human face here trying to discern pain. It's a little bit comical, right? And maybe not the most precise measurement, but just to drive home the point that this has been done and done again, right? People are trying to have more consistent or reliable measures for pain. And then we have a cute one down here, right? Maybe one targeted towards kids. Finn the human here, from the least amount of pain to the most amount of pain. So there are lots of research design issues we could delve into here, right? The difference between having text versus no text, the difference between, say, even culture, right? In this case, we have on the very far right of the bottom scale here, we see somebody in tears, right? So maybe somebody's in the worst possible pain, but they're not crying. So they might look at a scale like this and say, well, I'm obviously not in the worst possible pain because I would be crying, right? So there's a little bit of inconsistency to these ranks. But this is a great example of how this is the best we have for a particular variable, but it is still limited. So now moving on to the next type of data, we have what we call interval data or equal interval data. It means that the variables have values attached to them, or numbers, that stand for approximately equal amounts of what is being measured. Okay, so this is new from what we had before. There are equal distances between points on this measurement. And there's no true zero, okay? So just hang on to that for a minute. We'll talk about that on the next slide as well. No true zero, and equal increments between points. So the best example here is something like temperature. All right, temperature moves in equal increments in degrees, right? A difference of 5 degrees is the same whether you're in negative degrees Fahrenheit or positive degrees Fahrenheit. But there's also no true zero with temperature, all right? And what does that mean? The temperature can be 0, right? We have different scales where 0 means different things. In Fahrenheit, 0 just means pretty cold. Celsius, 0 means freezing, right? So 0 means different things, but 0 does not mean an absence of temperature, right? It does not mean an absence of temperature. So this is a conceptual kind of issue, again, that we'll address momentarily here. But that's what we need for interval data. And then let's move into ratio data. So ratio data is also equal interval. And it's measured on a ratio scale if it has a 0 point. That means that 0 on the variable indicates an absence of the variable. Okay, so this is just a conceptual difference. It's a little bit tricky, but for our purposes and for most research purposes, we treat Interval data and ratio data, the same. We treat them largely the same for analysis because they're both on equal interval scales. So some examples of ratio data would be something like weight, right? If you're trying to weigh a substance, if you have 0 of it, you will have a weight of 0, right? And that means the absence of whatever it is that you're trying to measure. A test score, a 0 would be the absence of a test score. An income, right? Can you have 0 income? Tragically, yes, right? Can you have negative income? Also tragically, yes, that's debt, right? So we can have negative income, we can have positive income, but what's important is that we have a true 0 that means the absence of the value. And even more so, we have equal distances between measurements on that value. So if we take money, we might be measuring in dollars, right? A dollar is the same whether you have negative 20,000 in your account or if you have positive 20,000 in your account. So that's what ratio data is, equal interval data, data that moves in equal distances on a numeric scale. This is most of the data that we will be using in the class. We will use some nominal data and ordinal data, but predominantly we use ratio data. This is what we can use to, say, get averages or run correlations. So it's the most practical, flexible data, we'll say. Doesn't mean it's most important, but it just means that we can run the most statistical tests on it. All right, and then I have just a little visual here for the 4 major types, their kind of main characteristics. So nominal data has distinct categories. Ordinal data is ordered categories or ordered, rank ordered values. Interval variables have meaningful distances, and then ratio variables have an absolute 0 point. And again, for, say, our exam, if you have to differentiate different types of data, interval and ratio will be treated as the same. Just conceptually be aware that the difference is the presence of an absolute 0. Then I'll go ahead and show you here. I have links to 2 other videos that review this, so if you're interested in those, the links will be available for you. And then that concludes our lecture on types of data. So next we'll be talking about analyzing, describing, and organizing data using visualizations, using histograms and frequency tables. So that's our next topic, and I will see you on the next one.